Just make sure. Okay, so I have a few little announcements to start off with, okay? So we are getting close to the end of the semester, so everything is getting a little bit rushed here. So PLQ3 is going to be due Friday. I know that already a few of you, maybe like 3 to 5, have been trying to log in, so I have some explaining to do here. So it's going to be due Friday for step 1, and then step 2 is going to be due the Monday after that, the same as GQ04, okay? The deal with PLQ3 is that the software has been upgraded. I did exactly what I would tell anybody working for me to never do. That is roll a new release, during a production cycle. So we'll see. That should work, finger crossed, but the reason I did that is because some of you shared actually some feedback about the software, and there were things that I wanted to address immediately, so I kind of incorporated that in one quick release, and here we go. Let me start by the annoying bit in all of this. You are going to have to re-register. Okay, I was not able to migrate actually the database as it is, so that doesn't mean anything for PLQ1 and 2. You still have your points, don't worry. Nothing is lost there, but we have to start fresh for this new release of the software. It's not backward compatible, so you have to re-register. Once you re-register, use the same email address, the same password, whatever you want. You can take PLQ3 and then you're done, okay? In terms of why we had to have a release, well, there was a bug fix actually that needed to be done, to be applied to the software. Some of you mentioned that the software as a page on step 2 was saying things like, you will find your answer pre-selected below. And there was nothing that was pre-selected, so this is taken care of. Sorry about that. In terms of features, you are going to get multiple justification now for each item, so that you can get a diversified viewpoint from your classmate. And also, if you get one of those justification that says, I have no clue, I don't know what to type here, or something like that, then it's going to mitigate that probability as well a little bit. There is a like feature in the next semester. I'll probably use that to incorporate it in the grading system, okay? But for now, it's just for you to notify that a specific justification from one of your peers was actually particularly useful. And then we have, after the end of the quiz will be released again and the solution will be posted. So you will see your pre-selected response when you look at the page, and you will see also highlighted, what was the correct answer for that quiz. So that's kind of like the summary of changes for this release. IE4, this is what I was thinking about when I said rush. IE4, we are going to have it next Tuesday. It's fast. It's really, really close to the previous IE. So I'm going to try to take some steps to make sure that, yes, we go a little faster between IE3B and IE4, but I'm not going to cause, damage to the students, pretty much. So IE4, the idea for it is focus on what we covered this week on Module 4. So you know how programming goes. I cannot guarantee that, for example, there's not going to be inheritance. That would be a lie. There's going to be probably inheritance. There's going to be all the stuff that we covered. But if I had to compare IE4, I would compare it to an exercise from this chapter on Module 4 that is completely focused on exception. Okay? That's my goal. My goal is we are going to cover exception and maybe a little bit of the file I/O this week. The focus on exception is going to be what I'm going to be testing for IE4. So that makes it a smaller scope, more narrower even if you speak correct English, and it's going to allow you to prepare for this one this week as we go through the lecture and we do the practice exercise that are related to exception. Again, only the exception part of Module 4, and then the final exam will have the entire Module 4 as the menu, okay? So that's how I'm trying to mitigate the crunch. And the time crunch, it's easy. Next week, we have Thanksgiving. The week after that, it's the official, what was called the reading days at USF. It's the no exam week. The purpose of the no exam week is to give you a buffer, okay, between the end of the course and the final exam. So during the no exam week, we can still continue doing lecturing, but we are forbidden to actually give anything graded to students. And I think that's a good idea. So that way, instead of focusing on one last exam, one last quiz or something like that, you can start actually focusing on preparing for your final exam. But that means that we have to stop anything graded right before that. I want to have one more IE Because the more IE that you have, the more chances you have to recuperate, from a bad grade in an IE or something like that. And that allows me to drop the worst one. So if I want to do that, I have a choice. I do it during Thanksgiving, or I can do it before Thanksgiving. I'm trying to pretty much make sure that you guys can enjoy a weekend of Thanksgiving, then focus on the final, and then be ready and do your best at the exam, okay? So that's the plan. But that means some of the things are going to be a little bit more rushed than I would like them to. Another announcement, end of semester evaluation are coming. We receive, as faculty, an email every semester that reminds us that we have to remind you, but more so than remind you, we have to help you understand how useful those evaluations are, not only for us faculty to understand what we do right and wrong, not only for the department to understand what the instructors and faculty are doing right and wrong, but also for you, so that indirectly we can actually improve the courses, okay? So this is, I would say, the first and only source of objective data that we can collect from students. This is your chance to have your voice heard. And when I say those things, I mean it for good or bad, okay? So it's very important that you understand that both positive and negative feedback have their role to play. For example, if we get only one feedback from one student out of 140 and it's positive or negative, this is a weird situation. Nothing is going to probably happen. The more students participate, the more students say, I like this, but I don't like that, then that feeds us information on what to stop doing and what to start doing more of, okay? And I would even put an argument here for, if you are on the fence, if you're like, meh, that's good for us to hear, because otherwise you just rely on the number of people that have something to complain about and the number of people that have something to be happy about to equate so that we reach a sort of equilibrium. Now, even if your point of view on the course is, I'm kind of in between, there are like 5 things I like and 5 things I don't like, mention it, okay? And that brings me to one of the next point here. You have open questions, so that's not that one, whatever. You have open questions in that survey. So the rating is very useful. You have a rating scale for all sorts of things, okay? That's very useful to give us an alarm signal. The rating is high, students tend to be satisfied. The rating is low, there's a problem. We need to investigate, okay? So the rating scale is very useful. But when it comes to go past the alarm signal and to actually understand what worked and what didn't work in a given semester, this is where the open-ended question shine. The open-ended question, you don't have to type like an entire page or so. I mean, if you want to, it's appreciated, but at the very least, try to provide some insight so that the rating becomes understandable. Because this is where, for example, I get my actionable items. I cannot get necessarily actionable items from a rating, because a global rating that tells me something didn't go right this semester, for example, okay, but which part? What do I need to change? Okay? So this is where those little comments that say, for example, I like this, but I didn't like that. This was too much work. This was not enough work. I would have wanted something more challenging. Anything you can think of. This is what gives us actually, when we aggregate it over all the students, a sense of really what happened this semester. So please don't simply select the rating, right? Put some comments in there, because this is really useful, and I read everything. I cannot guarantee my chair reads everything, but I do read every single comment, okay? Looking for stuff that I can use. All right, last thing, and then I will stop and we can jump in the course. Last thing, the structure of the survey is easily interesting. It's actually kind of smart in a way. It separates 2 things, the course and the instructor. While I can see why they want to do that, and I can see positive in doing that, okay, it's really confusing from the student perspective. Because from your perspective, or I should say most of you, I'm thinking that the course itself and the way it's delivered, these are like one thing. I'm taking COP2513 with this person, that's it. That's a whole package. When you answer the question in the survey, do your best, okay, it doesn't always work, but do your best to separate what you have to say about the course itself and what you have to say about the instructor. Because that helps also streamline the process. So when we review those things and we try to aggregate things, that helps us tremendously to not have just one evaluation that says, for example, whether it's positive or negative doesn't matter, but the evaluation says something here for the course, And then the second part of the evaluation says, well, I already evaluated the course here. So that means that we need to go back and try to detangle, okay, so which part, positive or negative, is due to the instructor, which part is due to the course itself, the content of the course, the learning objective and stuff like that. And that's not easy for us. So most of the time, we end up putting that in a third category, which is, I don't know exactly what the feedback was about, but I'm going to keep it, just in case I can sort it out later. And that's not as efficient, okay? So these are all the things that I could think of, besides making you understand that I really personally value those feedback that you leave, and that the department also value them. These are the best things that I could think of to try to maximize the impact of your feedback. So if you have any question about that, let me know. Right now, I don't have plans to have a session dedicated, to giving you like 15 minutes to take the feedback. I'm going to be sent probably an anonymous report in a week or so that says this many % of your students took the survey. If necessary, I'll make time so that you guys can take it comfortably in class. But if you can do it from home, that's probably even more comfortable, okay? And that would save us having to dedicate some time to that in class. All right? Any question about this, like all the logistic aspect that I covered, including the evaluation? We okay? Yeah.
So we do have the PLQ3 due Friday and then the Monday after. Do we have a PLQ4?
No. PLQ3 will be the last one. I cannot possibly fit the fourth one. We're like too tight. Yeah.
We have the IE next week and then the final.
So next week, you are going to have an IE. The week after that, the entire week, you have like review, and then the final. Correct. Yeah. Yeah?
And do we not have class next Thursday and next Tuesday, or just not next Thursday?
So next Tuesday, right now the plan is to have class. Okay. Next Thursday, no class. So Wednesday, Thursday, and the weekend should be pretty much like as much as we can make it, safe of pressure from this class. Oh yeah. Go ahead. So the IE is going to be at home, just as usual. It's the final exam that's going to be different. The final exam is going to be held on campus. You're going to have to bring your laptop. We discussed that like very, very beginning of the class, right? You bring your laptop, you take it on campus. We take it all together. It's going to be on a Sunday, I think. I must have been pissing somebody off. Oh, no, I'm kidding. But bottom line is we are going to come all together on campus on a Sunday. We have a block of 2 hours. More if you have accommodation, don't worry, but work with me. And we are going to take the final like this.
Okay, so the final's on the 5th.
The final, I think it's on the 5th, yeah. I'll double check. Like next lecture and the one after, I'm going to start putting reminders about the date of the final. But if you go to the final exam matrix, this is where you're going to find the date of the final. And I have not yet received the location exactly. So I'm still waiting to hear, exactly where is that room that's going to accommodate us all. But as soon as I know, I'll let you know. Yeah.
What time? That's
That's a good question. I think noon 30 to 2:30, if I remember correctly, but I'm just popping this out of my memory. 12:30 to 2:30? Okay, all right. Yeah? Yeah, I'm working on that, like the exam 3 week, okay? Generally, we can still continue lecturing. And sometime, if we are running a little late, I need at least a part of one of the 2 sessions, to finish up, wrap up a few topics. But I try to maximize the time that we can spend doing reviews. Right now, my plan is to come up with like a fake final exam and give it to you pretty much in class during the session and help you work through it. Okay, so that I can kind of a little bit individualize, instead of just giving the solution. This is the last chance that we have to catch actually people who are like struggling, and for me to help them pretty much like get ready for the final. Okay, yeah. Mm-hmm. So no class next week, Thursday. Okay. Class Tuesday, yeah. So quick curiosity, how many of you don't have class Tuesday? Okay, I was just wondering if I was a hard ass or okay.
So I assume we're allowed to use our books on the final exam?
Yes, I will provide, like a usual a slide that summarizes the rules of engagement, but you are going to be able to use your textbook. You are going to be able to use your slides. you are going to be able to use, of course, JGrasp, because you are going to still have to download a file. It's going to be very much like an IE, okay? The point of the IEs were to prepare you for the final and progressively get a little bit more complicated, a little bit more realistic, so that by the time the final comes, you are already comfortable, at least with the format. Okay, you know exactly what's going to happen to you. You walk in a room, you're going to look for the files to download, you're going to work on them, you're going to upload them. Okay?
What if our desks are like this?
That's what I've been working on. I've been working on trying to find us a room, and I don't know if this is why we don't have a room yet. But if we don't have a room, I mean, you guys take it from home. I don't have a problem with that. But right now, I'm trying to make sure that not only we have a room for the final where you can actually put your laptop and have a mouse or something like that, but I've been trying also to change our room, for the semester. It's just I was not able to get a decent room this semester, so that's why you guys have to deal with those little, things like that. Anyway. All right? Yeah?
Last question. So would it be after class that we take the IE, or?
That you take the IE? You take it like the other IEs. Okay? Like from home, there will be a deadline Tuesday, so Tuesday midnight or something like that. I'm going to see if I can make it Wednesday, just so that you have a choice. But Wednesday is starting to eat on the people that are going to travel for Thanksgiving, so I'm kind of pondering that. If you guys have feedback, feel free to express it on Piazza, okay? But I just want to try to be, I have to say, not too intrusive on the Thanksgiving weekend. But all right, a bunch of questions, good. This is where we stopped last time. So we were talking about exceptions. So this is going to be the menu for the next IE. We are talking about exception. We are talking about how to do error handling when you do not have exception. And we reviewed a few different techniques that we have used in the past, in this course, the semester, in COP2513, for those of you who took it with me. And it's not really entirely satisfactory. So now, at least, we reach a point where we are going to introduce this technique that allows us, in a nutshell, it allows us to tell the caller of a method something went wrong in a standardized way. This is really all that exceptions are about. They open a new communication channel between a method that has just been called and the caller. And it allows a method that has just been called to not return a value, or return normally, I would say, but take that safety lane, on the side that allows it to say something weird happened. Forget it, I'm not returning. You need to handle this differently. Okay? So every semester, students ask me at least one or two, could we have written things with exception by just making our own exception class and using objects and stuff like that? Not really. This is one of those things that has to be baked in the language itself. So in the case of Java, exceptions are in the syntax. There are classes to allow you to handle exception, but there is also a mechanics inside the Java virtual machine that allows it to pretty much return from a method call in a different way. And that we cannot invent it. As application developers, we cannot just add this to the language. We can add libraries, all day long. We can add like data structures, that are prepackaged so that people can reuse them. But when it comes to changing the way a method returns, this is like too deep inside the internal of the language. Okay? So every language that supports exception has this mechanic pretty much baked in. So this is very close to the example that we were looking at. As a matter of fact, this is the last slide I think that I had last lecture. We were looking at that method quotient with quotient, actually not with exception, that was dividing number 1 by number 2, and that was really being careful about not making a division by 0 happen. Now this is how it's going to look now that we're going to learn to use exception. So it's still the same logic, okay? And we still try to detect if number 2 equals 0. If number 2 equals 0, we know that the division is not going to work. So we take a step here to say pretty much return from the method, but raise an exception as you do so. Raising an exception means give me an object of a class or a subclass of the class exception, and I'm going to interrupt the execution. I'm going to take step to decide what needs to be executed next. Most of the time it's returning to the caller, and I'm going to give them that object. So that object of class exception or one of its subclass is where the information about what happened is going to be contained. So it's kind of like just our envelope, with a note in it saying, I just tried to do a division by 0. This is why I'm interrupting in regular execution, okay? And you see here the syntax kind of remind you of the fact that we are using object. So if you are like me, you forget all the time to use the keyword new here. You just say throw arithmetic exception, and between parentheses, you put a string that adds some information about what exactly happened, okay? So the fact that you throw an arithmetic exception means, okay, we have already 90% of the information. There was an arithmetic exception. That means a certain category, a very well-defined category of potential problem. But then you can add a string as a programmer that say, I was in the method quotient with exception, so you are pretty much trying to divide by a number of months that is 0. Something very specific to your application, to what you are trying to do. You would add this in the string here. And when the JVM explodes, right, and you get exception on the console, it displays exception, the name of the exception class that was used to give you an idea of what kind of error happened, and then it displays a message that the programmer left afterward as well on the console, okay? Like I said, I always forget to put the new here because I think in my brain, I think I'm going to throw an exception. So throw arithmetic exception ought to do it. Now, you are creating a new object of the class arithmetic exception. You are calling the constructor of arithmetic exception, and you are passing to it a string. And then that object is used by the throw keyword to interrupt execution, determine what we need to run next since there was an exception, and pass to that part of the code the object that you just created. Yeah?
So what is like the thread? The thread just stops the code?
It stops your regular execution. Okay, and I'm going to be more specific, like in a few slides, because it's not always return to the caller. Sometimes, if you are like in a try-catch block, it's go to the next catch close, okay? So I'm going to go over all the scenario, but pretty much a way to summarize it is to say you stop regular execution and you go into exception mode. Okay, so something happened. I'm not going to keep chaining sequential statement after sequential statement. I'm going to determine where I need to go, and then I'm going to deliver to that part of the code the exception object that contains all the information about what happened. Okay? From the calling point of view, from the main, I'm calling this method. There's going to be a little bit of syntax as well. In this example here, so I was reading two numbers from the user. I'm going to try to call my method here, but the keyword is try. I know this method can fail. Okay? I know there can be a division by 0. I know if my method was, let's say, reading data from a file, I know the file could be corrupted, the hard drive could be in flames, and so on and so forth. I could have no permission to read, etc. So when you call a method, or you are about to do something, and you know that something can fail in terms of exception, there's an exception that can be raised, then what you do here is you surround the code that is dangerous, between quote, you surround it with what we call a try block. So keyword try, yet another keyword, right? So we have the keyword throw, we have the keyword try, just to handle exception. Keyword try, open curly brace, close curly brace, everything that can possibly go wrong. And then, after that, you have a catch. So yet another keyword catch. You have a catch that specifies between parentheses, and somebody had a question on Piazza about that syntax, right? So between parentheses, what you say is, if any exception is raised here, in this try block, I'm going to check if it was an arithmetic exception. If it was an arithmetic exception, then the object that they are trying to give me, that the code that's failing is trying to give me to tell me what happened, is going to be available with the reference variable e or ex. Generally, we call them e or ex for exception, right? You can call them whatever you want. So that after that, I can specify the code here that has to be executed to recover from the exception. And to try to minimize confusion, if you look at this code, you could tell me, you're not recovering from anything. All you are doing is you are displaying on the screen, some information about division by 0 might have occurred. Granted, wait for the next slide. Okay, next slide we're going to do something more useful. Here, I'm just trying to lay down the syntax. So the basic syntax is whatever you have to do here to handle your exception, you do it there. And once this code is over, so if there was an exception in those 2 lines, it got caught up here. If it was an arithmetic exception, we execute this code. Once the code is over, well, we assume that we're good. So we go to the next statement after the whole try, catch syntax. So our code doesn't explode anymore because the exception, the division by 0 exception that we may receive is being handled here. And then whatever I do here is supposed to be enough for me to recover from the problem. And then I move on, I execute the rest of the code. So this is okay to show the syntax, that example. But this is not really how things are going to work. So we need a slightly better example, because see, when you run this, it just tells you pretty much on the console there was an exception, and then it says the execution continues. So the only thing we gain really is that execution doesn't necessarily stop. I could stop it myself by doing a system.exit, okay? But if I choose, I can resume execution normally. This example is a lot better. This is a good, actually, example. It's not like a trivial example just to show the syntax. It's an example on what some of you have been waiting to be able to do since almost day 1 in COP2513, okay? Where I started telling you, well, you can read a number from the user. You can read an int from the user. And then immediately some of you try to ask, what happens if the user types hello instead of an int? And I told you we are going to trust the user, and we have been trusting the user for 2 semesters. See where that led us, right? Never trust your users. We need a way actually to handle when the user doesn't play by the rule. I ask them, enter an int value between 0 and 100. I already learned to deal with the fact that they might be out of range. Now I want to deal with the fact that they might be, let's call it, out of type, out of data type. Okay, they give me a string when I ask them for an int. So this is exactly what's going on in this code. Let's take a look at what we have. We have a scanner input. We have a Boolean continue input true. So there's going to be a logic here that says keep asking the user for more data until they get it right. Okay, and that's going to be pretty much set in that Boolean continue collecting input pretty much. Do while, okay, do while continue input. So this is my repeat of the whole process. The whole process of reading something from the user, making sure it's correct, and moving on with it, okay? So do while continue input. So as long as I don't change continue input somewhere in there, I'm going to do that forever. So somewhere in there, I'm going to change continue input to false. There we go. And that's what's going to get me out of the loop. Inside the do while, I have a try. This is a try part. This is the stuff that's risky, okay? And then a catch that's telling me what I should do if a specific exception was raised by any part of the code here. The exception that I'm concerned about is called input mismatch exception. That one, the title is kind of clear, okay? That means that somebody gave you the wrong data type in an input to the program, okay? And that can be, again, reading, from the keyboard, from a file, from a network connection, from whatever. If there is an input mismatch exception in any part of this try block, okay? What we do is we display try again, incorrect input, integer required. So we display an informative error message to the user, and then we say, let's read the rest of the line. So whatever the user typed, let's kind of like clean it up so that we can start fresh and have them give us again, have a chance to give us, the int that we are asking for, okay? So that's what we do if there was any problem at all occurring here in the try block. And then we reach the end of the loop. We didn't change continue input. So continue input is still true, and we go at it again. We try again. If it fails with an exception, we catch it. We display an error message. We try again, and so on and so forth. What about the try block? What do we do exactly in the try block? So we ask the user, please enter an integer. We read that integer from the user. We display the number is entered was blah, and then we say, okay, now that I have my number, continue can be false. Once I'm done executing all this, I skip the catch because there was no exception raised, and I detect while continue input is false. That's it, I'm out of the loop. So that's a scenario where everything went right. And this is a scenario where things went wrong. This is where things can go wrong. Int number equal input dot next int. This is a call to a method that has a chance to raise an exception, and more particularly to raise an input mismatch exception in case the user is not playing nice and not entering something that looks like an int. If this is the case, if the user enters like a phrase or something like that, okay, anything like text, this is never going to return. That's the thing with exceptions, remember? The method doesn't actually return. So I never get a value inside of int number. This assignment here, not happening. So what happens as soon as I return from a method, but not the usual way, the exception way? Well, I'm going to be in my try block. Does here raise an exception? Immediately that causes me to jump to the catch clause. And I check what kind of exception was raised. So you notice that I skipped all of this. Okay? If this didn't work, then I don't have a number to display. Then I should certainly not set output continue to false. That's the whole point of exception. You are in a try block. Once the exception is raised, you jump out of it, you get to the nearest catch clause. And if we match this exception, then we trigger this code here that does what we already discussed, and then we loop again. So this is more useful. We are going to keep looping until the user gets it right, and each time give the user feedback about, I need an int. Don't type this, I need an int, etc. So this is actually a realistic example of error handling with exceptions. So I gave you an example, two examples of exception. One that was really basic, just to show the syntax. One that was actually a little bit more realistic, that shows actually the structure. And I would say that most of the time, that, or at least for this course, for what we are going to do with exception in this course, that structure that I just showed you on the previous slide is going to be a pattern that you can reuse, okay? Because it shows, repeat of trying something until we pass, we don't have an exception. Now, what we are going to talk about, well, you saw me use the name arithmetic exception and the name input mismatch exception. Where did I pull those from? So there is no way for me to remember all the exception in Java. If I was using them on a regular basis, probably I would end up remembering them, okay? I don't use them in a regular basis. You are not going to use them often enough so that you familiarize yourself. So you need to know where to find that information. For the course, it's easy, textbook. The textbook lists, okay, a bunch of those exceptions. You need to know where to find that information in the textbook so that you have the name of an exception and what it covers. And if you were in the real world, not just taking a class on Java, then that would be the Java official documentation website. Okay? You look up exception, you see all of the exceptions. As a matter of fact, you see something that looks like this. This is actually the exception classes that are available in the JDK. And, surprise, surprise, they are organized as an inheritance hierarchy. We have the object class here that has really nothing to do with exceptions, except that it's a superclass of everything in Java. Then we have a subclass of object which is called throwable, that I cannot absolutely pronounce, so good thing it's written on the slide. That thing means anything that can be thrown by the keyword throw, okay? We're not going to use that one a lot. It's more of a way for the developers to abstract a bunch of things and factor them there. Then we start having the useful class, especially this one here, exception. So we have exception and error. So you see already that we have we have divided exceptions in two categories. One that's called exception, one that's called error. And we're going to talk about what they correspond to. And then inside exception, we further differentiate. We have class not found exception, I/O exception, so I/O input output when you're trying to read or write data on a disk in a network connection or stuff like that. There are a bunch of classes here, and there is one of particular interest again called runtime exception. And runtime exception is interesting because it has also subclasses such as arithmetic exception. Well, we saw that one, okay. Null pointer exception, some of you had the displeasure of meeting that one while you were programming, right? You have a reference variable, somehow it contains null. You try to use reference variable dot something, an attribute to a method name, bingo, a null reference exception, null pointer exception, okay? And then index out of bound, again, most of you encountered that at some point. It's you are working on an array, and suddenly you try to access something that has a negative index or that has an index that is larger than the size of the array. And then illegal argument exception. So this one is rarer in COP2512, 2513, but it's when you pass the wrong data type for a parameter. Okay? And there are more. So there are a ton of them. But what we're going to try to do during the lectures is I'm going to try to give you a sense of the map that those exceptions follow. And then, when you need the name of a specific exception, there is no magic. You have to look it up. Look it up in your documentation, your textbook, or whatnot, okay? But right now, let's try to keep a focus on the general organization of this mess. So we are going to start by the bottom. We're going to start by the class error and all of its subclasses. So they form a very specific group of exceptions. They are called system errors. We are not going to have to deal with those a lot. Generally, a programmer doesn't have to deal with those kind of exceptions a lot, simply because they are really, really harsh. They are pretty much unrecoverable. If you take a look at what we have, like the kind of exception that we have, linkage error. What the hell is linkage? Well, linkage is the last step, one of the last steps of compilation, the compilation process, that allows you to put all the pieces of your code together. In modern language like Java, sometimes you load some of your code at runtime. It's not something we have experience with, but it's possible in Java. So if you were trying to load a plugin, for example, at runtime, and for some reason it doesn't work, then you would get one of those errors. What am I supposed to do with this? This is really a catastrophic error, right? So is virtual machine error. I'm not even sure even what this one corresponds to, because it's so vague, okay? That means something in the Java virtual machine just broke. It might be your fault, I don't know. It might be just a problem, a bug actually with the JVM. Bottom line is the car we are riding in just exploded. There's really not much we can do except, like trying to put out the fire on ourselves or something like that. So our program is the last of our worries. The JVM itself just collapsed. Okay? So those kind of error, they are kind of integrated in the exception framework just so that we have a way to stop execution of the program and stop the JVM altogether when we need to. Okay? And display some error message that's going to hopefully be meaningful and try to handle it that way. So we are back to the very brutal way to handle error, but we don't have a choice. Okay, for example, if you run out of memory, if you have a recursive method, we didn't talk much about recursive method, but if you have a method that keeps calling itself always, like we had some constructor go awry like that, if it keeps calling itself and it keeps creating activation records, you're going to eat up your memory little by little, and then after like a few seconds of that, the JVM is going to crash with an exception. Okay? So that's the kind of problem that we're talking about here. The second group, which is much more interesting from the perspective of an application developer, okay, is the class exception and all of its subclasses. So now we're talking about the difference between exception and error is now we're talking about problems that can be traced back to somewhere in our code. So it's no longer the JVM ran out of memory or something like that. It's really we are doing something and that something is not working properly. So chances are that we can mitigate it. Chances are that we can recover from it. Okay? Example, I'm trying to read data from a file. I get an exception. The exception tells me you don't have read access. What am I going to do? Well, depending on the context, I might want to pop up a modal dialog to the user if I'm in a user interface of some sort, okay? And tell them you don't have permission to read this and this and this file located in this and this and this folder. All right? Go ahead and fix it. Click OK when it's fixed. So I kind of let the user go and fix that problem because that problem is external to my program. Okay? Same thing with those floppy drive. You try to read data from a floppy disk. The floppy disk is not inserted in the drive. You're going to tell the user, go ahead and insert the floppy, log the drive, and then I can resume my execution. Okay? Those kind of problems. All right. So we should be able to handle most of what happens here and hopefully recover from it. But I'm going to look at one subcategory of exception that is of particular interest. This is called runtime exception. And these have the nasty quality of potentially happening a lot. And I'm going to say more about that in just like a second, okay? So what I mean by they have the nasty quality of potentially happening a lot is, look at the kind of error we have. Null pointer exception. When can this happen? This can happen anytime you use the dot notation with a reference variable. Literally. Okay? Arithmetic expression. That can happen potentially anytime you have an expression that does some arithmetic operation. Like anything from incrementing by 1 a counter or something like that to implementing a complex formula. Okay? So the common thread between all of those exceptions, because these are still exceptions, okay, they are subclasses of exception. The common thread of all those exceptions is they are programming errors. They are things that we should have seen coming. I should have seen coming that this variable, for example, this reference variable or that reference parameter was null. I should never try to use a reference parameter, for example, before checking that the caller didn't give me a null for it. Okay? If I divide by 0, I should have seen that coming. If I have a denominator or a numerator, I need to check that I'm not going to divide by 0 every single time. That's part of writing robust defensive code. Okay? All right, so this is pretty much this category is like it's your fault. You should have done better. Your code should be written differently to avoid those exceptions. And we're going to see why it matters. So it matters because on top of this hierarchy, okay, on top of this organization of all the classes that correspond to exception, we are going to look at them also from the perspective of two categories. Unchecked exceptions, and then the second category will be checked exceptions. So let's start with unchecked. Everything that is highlighted in yellow is called an unchecked exception. So that includes all the error class and all of its subclass, and all the runtime exception class, and all of its subclass. Okay? What does that mean to be an unchecked exception? Well, that means pretty much this is really not easily recoverable. Whether it's a system error and everything crashed, or you wrote your code poorly and you should have done it differently, what the message that's trying to be passed here is, I'm not going to force you to pay attention to those exceptions. That's why it's called unchecked exception. Even for all of those problems could occur and sometimes occurred in our code until now, okay, we never had to use a try-catch block. We never had to learn about throw and stuff like that. We were just ignoring those potential problems. And that's what the category of unchecked exception is. It's a way for the Java compiler to tell you, you may ignore exception when it comes to those topics. Okay? And again, the logic is, well, for the error, you don't have a choice, pretty much. And for the bad programming, well, if you have a badly written method, it's going to crash. But guess what? You're going to fix it, right? So this is why we are allowing ourselves to ignore those exceptions. That doesn't mean that you cannot try to catch them, okay? So you can put a try block and then catch those exceptions and react to them like we did with arithmetic exception. You can definitely do that, but it's not mandatory, okay? And it's going to be mandatory, guess when we deal with checked exception. So everything else is mostly subclasses of exception and exception itself, okay? Those exceptions here, they are going to be looked at as checked exception. And checked exception means that you have to pay attention to them, you have to handle them. If you ever use a method that might, for example, throw an IO exception, when you call that method, you have to put it in a try-catch block. It's mandatory. So you see now why we have this distinction also between checked and unchecked, right? There's like a handful of checked exception, and every time you use a method that may raise it, not even if it never raise it like in 100 years, doesn't matter. If it may have the potential to raise that exception, you have to add code around the call to the method to do a try-catch block. So imagine that you had to do this for every arithmetic exception. Every single time you use a plus, minus, multiply, divided operator, modulo, you have to encase that in a try-catch block. Every time you use a reference variable, you have to encase that in a try-catch block. Java has already the reputation to be a very verbose programming language. If we had to do this kind of stuff, that would be nuts. Okay? Our code would be super long. There would be exception catching everywhere. That's why we ignore those things, because we can remediate them differently. But those things here, like when you read a file, yeah, you should expect and handle an I/O exception, because we know that when you read a file, things can go wrong that are completely beyond the control of your program. Okay? So that's the jungle out there. That's the set of all exception classes, pretty much what is the logic behind their organization and what some of them do. I mean, without us actually forcing it, you already know pretty much about arithmetic exception, illegal argument exception, and a few of them, null pointer exception, stuff like that, okay? So this is how you're going to learn about them, by practicing a few of them. And in the course, we're really going to focus on a few of them. Now, how do we use them? So the whole syntax was already illustrated in that example I had at the beginning. What I need to do now is I need to formally revisit the rules for each of the parts, the try, catch blocks, the throw, etc., and make sure that I convey to you all of the options that are available for each of those constructs. Okay? So we are going to revisit our basic example, but try to focus more on what else can I do, what are the options available. So here's an example where we have one method, method 1, another method, method 2. Method 1 at some point is going to call method 2. And method 2 is one of those methods that has the potential to raise some exception. So how do we know which methods have the potential to raise an exception and which method do not have the potential to raise an exception? Because methods are going to tell us here. They're going to tell us if they have the potential to raise an exception. So this part here, this part is catching the exception. I try to do something, I know it's risky, so I put it in a try block, and then I have catch statements that are going to respond to pretty much every type of exception that can happen. The second part is declaring exception. Every time I have a method, and that method should actually potentially raise an exception, I need to add something to the declaration of the method. So the throws keyword, for example, is going to tell me this method 2 here that I'm declaring right now throws that exception. And I use the name of the exception class, to say which exception or exceptions, plural, I can throw. And then the last part is actually somewhere in the code, when I detect that something went wrong, like the file I'm trying to open is not there, doesn't exist, or the file I'm trying to read, I don't have read permission on it. When I realize something is going wrong, then I use the keyword throw, create an object of one of the exception class, and throw that object up the stream and say, okay, execution has to interrupt, regular execution has to interrupt, figure out where we need to go next, and deliver that object to the catch block, that's going to be ready to receive it. Okay. The only thing to be careful about, throws. We all mess it up, Like I said, if you use exception every day for like 6 months, you'll be cured. But if you just use them once in a while to teach them, or because you are being taught exception, it's not enough to get memory muscle. So these are the little things that I want to warn you about. So throws, a method throws an exception. That's a declaration. And then when you actually want to throw an exception, you use just throw. Okay? So it kind of makes sense if you read it like that. A method throws, but now inside of my code, I throw an exception. All right. And if you get some complaint about the compiler, always think that's first. 90% of the time, that's going to be the problem. So now that we have this outline, declaring, catching, throwing, etc., let's go one by one. So what else can we say about declaring exceptions? So this is when you write your method. So that statement, throws, followed by the name of one exception class or multiple exception class separated by comma. Please note that it comes between the name of the method and more specifically after the end of the closing parenthesis where all the arguments are, and before the opening curly brace. So it's still part of what we call the method header, the method signature. Okay, it's not in the body of the method. It's not between the curly braces. Okay. One thing that I need to start elaborating on that a little bit. You know, we made the distinction between checked and unchecked exception, and I told you, well, unchecked, you know, we can let them go pretty much. We can let them happen. The compiler doesn't force us to do anything about them. Well, this is where it starts mattering. Okay, this is where it starts to matter. When I declare public void my method, and I say it throws IO exception and over exception, so yes, we're going to be able to do our own custom exception. So when I write this, I have to write it if those things here are actually checked exception. If any of the exception I may potentially throw is a checked exception, the compiler will force me to declare it when I declare the method. Every method must, think of it this way, every method must come clean. Do you have any checked exception that I should know about? It's like a TSA check, right? Do you have any checked exception in your luggage that I should know about? Yes, here we go. This method throws this, throws that. What about unchecked exception? I can put the name of unchecked exception here. Okay? You can go up to a TSA agent and say, I have a fanny pack with a pocket inside. It's going to look at you like you're nuts, but because it doesn't care. But the bottom line is like you can over-declare. That's not an issue. But there is a minimum. So if you don't declare anything that is checked, category checked exception, you're in trouble with the compiler. If you declare all your checked exception, you're fine. If you declare all the checked exceptions that you may throw, plus a bunch of unchecked exceptions, like, oh, I may have an arithmetic error, I may have, you know, all of those, sure, why not? You are allowed to do it, okay? But it's kind of redundant. All right, what else? So this was for declaring exception. Now let's revisit a little throwing, the actual throwing of the exception. So I throw this exception in that part of the code once I detected something is going wrong. So the syntax we're going to use most of the time is this one. Throw, new, the name of the exception class, parentheses, and generally speaking, when you create an object of a class exception, between the parentheses you will have a string. Okay, the default constructor takes a string actually that allows you to give more information about what's happening. So throw that new exception. But there's nothing magical behind this statement. What I mean to say by that is all we are doing is we are using a new keyword, yes, so that's the magical part if you want to call it that, but we are just passing an object to that keyword. So that means that we could declare a reference variable EX of type the exception, create an object of type the exception, call the constructor on it, and then assign the reference to the reference variable. And now when I want to throw that exception, I just refer to it through the reference variable. And that's it. So it's really the only new thing is the keyword throw. Okay? And that, yes, that is magic. That happens inside the JVM. We cannot reinvent it. But other than that, the exception itself, like the object that represents the exception, is just an object from a class. And if we want, we can create an object of all of those exception class, any of them. And if we want, we can even subclass any of those exception class, create a subclass of our own. That's how we are going to make our own custom exceptions. Okay? We subclass one of them, like arithmetic exception, sorry. I subclass it, and now I can add more stuff, more specific stuff to my problem that I want to represent with a new exception class. Okay? So we're not going to do that too often, but it's good to know that the option is available. So we put all of this together, and what do we get? So here we have like the part that's declaring and throwing the exception. So this is what happens inside the method where you may potentially detect a problem. So void, for example, set radius, you remember maybe that one. That was the example of my simple circle or circle, whatever the class was named. We had a set radius method, and we didn't want a negative radius. Or actually, as a matter of fact, we didn't want a radius of 0 either. It's a circle, not a point, okay? So we used different techniques to make it happen before. Here what we are doing is we are going to use exceptions. So first part, declare that the method, the setter method here, may throw an illegal argument exception. I told you real quick in passing, illegal argument means you are passing the wrong type of data to a method. Well, yeah, that's kind of the situation here. So I started with my concern. My concern is I have a set radius, and I want to tell the caller that they did something wrong if they give me a negative or null value. Then I looked at the catalog of exception classes in the JDK, and I found one that kind of matched the meaning of what I have, the problem that I may have. That was illegal argument exception, so I adopted it. So now I say this method may throw an illegal argument exception. And then inside the code, if the new radius is greater or equal than 0, then please proceed, assign the new radius value to the attribute radius, else throw the exception. So now I'm using the keyword throw. I'm creating a new object of the class illegal argument exception. So this name that has been declared here will match the name that is being used here to create the exception object. I provide some additional information, so the radius cannot be negative. So that's specific to this method, to my application, to what the programmer knows about what's going on here. And I throw this, and that's it. So instead of just saying if you try to set a negative or null radius, I'm going to set it to 1, this time I allow proper notification of the caller, the code that calls my method, that they did something wrong. They gave me a radius that was negative or null. Third part. Yes, question?
The last slide,
Yeah.
for the illegal argument exception, can you use arithmetic exception in this case?
So you have to try to find the exception that match the best, your situation. You could say, for example, if you give me a radius that's negative, I'm going to throw an arithmetic exception. At the end of the day, what matters is what's in your documentation. So if you deliver a class to me and you tell me I have a set radius and the set radius declares, this and this and this and this and this exception, somewhere in your documentation you'll go ahead and tell me a little bit more. You'll tell me, for example, I raise an arithmetic exception when the radius is negative or null. And you could choose that one instead of the illegal argument. That is completely subjective. Okay? From Java perspective, it's actually an interesting question because it stresses out that from Java perspective, it's an object. It's an object of a subclass of exception. So Java really doesn't attach more meaning to that. The thing that Java attaches meaning is whether you have a checked or unchecked exception, because it enforces things based on that, okay? But other than that, I could try to throw like a weird exception that has nothing to do with my problem. But then, again, this is a kind of situation where the compiler lets it go, the JVM runs it, and then you go back to your parking lot and your colleagues have been keying your car, right? Because they're fed up with you being like quirky with those kind of things. So there we go. So what about catching exceptions? So the try-catch syntax. The first thing I want to mention is that the try-catch syntax is not limited to catching one type of exception. You say try, open curly brace, close curly brace, you put the code that is potentially dangerous here, that has the potential to raise an exception, and then catch this type of exception. Do whatever you have to do. Catch that other type of exception. Do whatever you have to do. If an exception is raised, one of those catch blocks is going to be triggered. The one that specifies a data type here, like a class name, that matches the class of the object that was sent. So again, this is about like the documentation, right? If you told me you are going to throw an arithmetic expression if the radius is negative, then I'm going to catch arithmetic expression, and then I'm going to do something based on that. Okay, you told me that that would mean the radius is negative. Now I need to try to mitigate this. Okay, so you can have multiple catch. They are all looked at in order. So when an exception is raised, we first check that the object of class exception matches that data type. If so, we trigger this, and then we're done. If not, then we check the second catch. If we trigger it, we execute the code here, and we are done. If not, then we skip to the next catch, and so on, so forth. Okay? All right. So that's the syntax. We covered everything about the syntax on exception. So there's not that much. Actually, when you think about it, there's not that much new syntax. Yes, there are like 3-4 keywords and stuff like that. But generally speaking, students have no problem getting used to the syntax. All it takes is, out of the 4 practice exercises that I recommended for this module, remember, the 2 first are on exception, the 2 after that are on file I/O. Do the one on exception right now. Okay? Don't wait for the weekend. Try your hand at doing them between now and the next lecture. If you get stuck, Piazza, office hours, whatever. But my point is, expose yourself hands-on to exception right now, so that during the next lecture we may wrap up exception, address problem that you encountered, finish up, like the concept that we need to add, and then you'll be in good shape to finish preparing over the weekend for the next IE. Okay? That's the plan. That's the road plan. All right. What I need to explain a little bit more, and we're going to probably finish up with this, given the amount of time we have left. What I need to explain a little bit more now is how exception behave at runtime. There's always that duality, right, with code. I show you the syntax. I show you how to write the code. You write the code in a Java source file. You compile it. That's it. It's compiled. It's working, right? No, it just compiles. And then when it runs, it has a life of its own. So there is always compilation time, runtime. And if you notice, we talked about exception only from a compilation time perspective, almost exclusively from a compilation time perspective right now. So now it's time to look at what happens when an exception is raised, and how potentially an exception can propagate throughout your entire code. Okay? So the thing with exception is that they bubble up or bubble down, depending on how you want to represent it graphically. Okay? Meaning that once an exception is raised, it calls for somebody to handle it. Like right now, right here. Am I in a try block? If I raise an exception in a try block, inside a try block, right? If I write throw exception inside of a try block, then immediately it goes to the first catch and check for the type. Then if it doesn't match, the next one, the next catch, the next catch. What if I go through all of the catch statement and I don't find a single catch statement that is capable to handle my exception? Where do I go next? This is why we use the term bubbling up. We are bubbling up the program's execution stack, the stack where all the activation records are put. Just as a quick reminder, when you start execution of your application, you enter the main method. When you enter a method, a chunk of memory is put on the stack. This is where all the pretty much local variable parameter for the main are going to live. The main calls another method. This method is going to need some memory. Here's a block of memory where all the parameter local variables are going to be stored. This method calls another method. Again, this method needs also a piece of memory. So I have 3 cubes like that stacked, and the name stacked, in an area of memory. That's the program's execution stack. These cubes are activation record. So what happens when you fail to handle an exception inside a method? It bubbles to the next method. The next method being the one who called you. I called you, you encountered an exception, you're not able to handle it, you report that to me. I don't know what to do with that exception. I'm going to report back to whatever method called me that, you know what, I have an arithmetic exception. I didn't get the arithmetic exception myself, but one of the methods I'm using reported that there was an arithmetic exception somewhere. So I'm just passing the message because I don't know what to do. And we can have a chain, an entire chain of method calling another method, calling another method, calling another method. The one at the bottom realizes that it cannot do the job, and the message keeps being back propagated like that Up to where? Well, hopefully one of the callers at some level is going to say, well, you know what, I tried to do this, it doesn't work for whatever reason, I know what to do to abort, to mitigate, to recuperate, okay? If not, then it's going to end up going up and up to the main method, right? Because the main method is the first method that's executed when you start your app. And in the main method, again, you have a choice. Can you do something? Can you handle the exception? If yes, well, we had to go all the way up, but finally somebody can do something about this. Or if you cannot handle the exception, what is the next step? Bada bing, bada boom. You actually let the exception bubble all the way to the main, and then bubble up from the main. It hits the Java virtual machine, and that means that pretty much everything fails. So by everything fails, I mean the JVM stops execution, display on the console an error message that's going to say something like, exception, the name of the exception class, and then the string that the programmer provided if they provided any additional information. And you've all encountered that. You're running some code. So we've had exception all along, right? But you're running some code, an exception is triggered somewhere, but we didn't know how to handle exception. So it bubbled up all the way to the main, and then finally showed up on our console with the program crashing. If at any point you catch the exception, that's where it's interesting, because if you catch an exception, you execute a little bit of code to remediate the situation, and then you continue executing the rest of the stuff after the try-catch block. So as long as you know what to do to fix a problem, then you can continue running. You don't have to have your JVM explode. So that's the generic rule, and we are going to look at how it depends on a specific example here. I have a method. This is going to be my main method, okay? This is pseudocode. This is not real Java, but I have my main method here. Somewhere it called method 1. Inside of method 1, somewhere I call method 2. Inside of method 2, somewhere I call method 3. That's pretty much, the flow of control, like the regular flow of control. And then I'm going to add exceptions on top of that. So I'm going to consider that method 3 is going to raise different types of exception. And I'm going to look at what happens when it raises this or that type of exception. So, first example. Let's say that method 3 raise exception called exception 3. So that would be a subclass that I created. It's a custom exception, doesn't matter really. But what matters is that as soon as it raises exception 3, I skip statement 5. That's the point of exception, right? You skip whatever is left in the try block. You jump to the catch and you check. Can you catch exception 3? Yes. So I'm going to execute this. I'm going to process exception 3. And then I'm going to resume execution at statement 6. When I reach the end of the method, I'm going to return here, finish executing this. When I finish this, I'm going to return here, finish executing this. So almost everything went normally. I handle the exception that method 3 raised inside method 2, right here. Okay? Second example. Method 3 raised an exception, so that didn't change. But this time the exception it raises is called exception 2. So what happens? As soon as the exception is raised, I skip statement 5, I go here to the catch, but the catch is unable to handle exception 2. So I skip the catch, and where do I go next? I return from method 2, and I raise that exception that I was not able to handle. So now method 1 is looking at method 2 raising that exception 2 exception. What happens? Same thing. I skip statement 3, I jump to the catch clause, and I check, can you handle exception 2? Yes. There we go. Process exception 2, then execute statement 4, reach the end of the method, return here, execute everything, reach the end of the method, the application is done. Okay? So we recovered from that problem as well, but we recovered in the method that calls the method that calls the method that had a problem. And of course, it can go all the way up back to the main. Okay? So if method 3 throws exception named exception 1, I skip statement 5. Can I catch exception 1 here? No. Jump out of the method, raise an exception. I raise exception 1, skip statement 3. Can I catch exception 1? No. Raise an exception. Pass the exception to whoever called you, I should say. I raise exception 1, skip statement 1, catch exception 1, execute process exception 1 here, then go execute statement 2, then finish my application, and everything is working. And like I said, what if we go all the way up to the main method and then we don't catch it? So it's not an exception 3, it's not an exception 2, it's not an exception 1 that method 3 is raising, it's something else, exception 42. Well, it's going to bubble up all the way to the first method that was executed in my application. That method is not going to be able to catch the exception either. Therefore, I'm going to skip statement 2 and crash my JVM with an exception message on the console. Okay? So, review that example between now and next lecture. Okay? Review that example and focus on, there is one rule really. There's only one rule that applies, but it applies, kind of recursively at every level. It's kind of like Russian doll syndrome there, okay? So make sure that you view it that way. If not, come to office hour, ask for help. I'm going to finish with 2 quick remarks regarding exception handling. The first one is we are using classes and subclasses, right? And we specify names of classes in the catch block. So what happens if my first catch block is catch exception, and the second catch block is catch arithmetic exception? I'll never trigger the second one, because no matter what exception I have, it's going to match the first data type. Why? Because of polymorphism. Where did we encounter that before? When we used instance of, when we use the instance of operator, okay? If I was testing if something is an instance of employee, and if it's not, I test if it's an instance of faculty, right? Wait a minute. If you give me an employee, of course it's an instance of employee. So the first one triggers. If you give me a faculty is an instance of employee also, because faculty is a subclass of employee. So I told you when we started using the instance of operator, that the order in which you look at the types, pretty much, of your object matters. The order in which you put your catch statement also matters. You have to know that it's a hierarchy of classes. You have to start with the most specific and work your way to the most general. So if you ever have a catch exception E, well, since exception is actually the superclass of all the exception that we are going to handle, errors, we don't handle them so much. But since it's a superclass, that one should always be last. If it's first or whatever, you're going to have a problem. All right? Okay, we're going to wrap up here. Thank you for your attention. And then if you have questions, I'm going to hang around a bit.